Alright, this is going to be a walkthrough on how to set up PBR materials in Blender. I'm going to be using Blender version 2.92, but you can use pretty much any version after 2.8. If you don't already have a material that you want to set up, you can find really good high-quality PBR materials for free off of TextureHaven.com, AmbientCG.com, 3dtextures.me, ShareTextures.com, CGBookcase.com, and FreePBR.com, just to name a few. There's definitely more out there, but those are just websites that I've found that have really good high-quality content, and in some cases, a lot of it. For this tutorial, I'm going to be using RocksGround 02, and I'm going to be using the 4K JPEG version of this material, but usually you only really need the 1K JPEG version. Anything beyond that, you don't really need that level of detail unless you're going to be closer to that material or whatever, and even then it's not really that necessary. You're just using up GPU texture memory space that could be better used for something else. And if you use too much GPU memory, so if you use all 4K or all 8K textures, you're just going to run into errors, and it's a bad time all around. So just trust me and use the 1K version. You won't really need that extra detail that comes with higher resolutions. So I've downloaded all the maps. I've got them in my downloads folder extracted. I used 7-zip to extract the zip folder, but you can use Windows File Explorer or whatever archive software that you prefer. So let's just hop into Blender real quick. I have a custom startup file, so things are in different spots, and I've changed the interface to green because I like green. But it's still Blender. Things are just in different spots sometimes, and I don't know. It shouldn't be that different. We're just going to hop on over to the Shading tab, and this is the space that we're going to be working in for most of the video. We have our node editor over here on the left, and then our viewport on the right. And then I have the object outliner over here where you can select the different objects on the bottom. So I'm just going to change it to rendered mode by going into the top right over here and selecting the viewport shading. Or you can do a quicker way you can do this is by holding down Z and just moving your mouse and selecting towards whatever option that you want. So I'm just going to stick with rendered mode. I'm also going to do a little bit of scene setup over here. So I'm just going to move this light over here, increase the radius, and duplicate it, move that one over there. Change this to a warmer color, and change this to a cooler color, just so that we have a little bit more contrast. And I'm also going to boost the intensity of this light by 2, and I'm going to use asterisk to multiply, and we're multiplying 1000 watts by 2. So that's just a quick way to change values if you weren't already aware. And we're not going to stick with just the default cube here, so we can see what the texture looks like mapped to different objects. So I'm going to hit Shift A on the keyboard and add a plane. Then I'm going to tab into edit mode and multiply this, or I'm going to scale it by 2, so that's hitting S, and then 2 on the keyboard, and then hitting Enter. And then we're going to also add a monkey, scale that up by 2, and a UV sphere, and scale that up by 2. And we're also going to set the sphere to smooth shading. So let's hop on back to the Shading tab, and you can see that we have some okay lighting. It's better than before. And we're just going to select all of our objects, hit New up here in the node editor so we can create a new material, and then we're going to hit Control L on the keyboard, and then we're going to link the materials. So what this means is that all of the objects that we have selected in this darker orange color are going to take on the material of the object that we selected last. And that's the object with this lighter orange. So you can see, but if we select all of these objects, they all have material 001 and not just the default material. And this is useful when you have multiple materials and you just don't want to be clicking on each individual object and setting the material. So if we go over here to the left side of the screen on the node editor, we have the Principled BSDF node. And we're just going to stick with this for the entire video, the entire tutorial, because it has all of the settings that we need. There's the metallic property, specular property, specular tint, which we're not going to use pretty much ever, roughness, anisotropy, sheen, clear coat, index of reflection, transmission, emission strength, and alpha. So each one of these sliders controls a different property, as you might guess, and we can hook up different nodes to these. So all of these can be controlled by image textures or values or pretty much whatever you want. You can hook almost anything into anything. So first of all, we're just going to start off by getting our base image map, so just the image texture, onto all of these objects into our material. So on the node editor, we're going to hit Shift-A. So that's going to bring up this nice add dialog over here that has all these subcategories that I never use because it's too hard to memorize where things are. We're just going to click on search and add a image texture. So we're going to hit enter and then select the open button. Go to wherever our textures are located. So for me, that's in the downloads folder. And in the top right over here of our open file dialog, I'm going to switch the display mode to thumbnails. So now we can see all of our texture files. So we're going to grab the one that's labeled COL, or in other cases it might be called Albedo or Diffuse, depending on who makes the texture. And then we're just going to double click it or press open image, and that opens the image in Blender. So now we're just going to take the color output of this image texture node and drag it into the base color input of the Principled BSDF, and you can see that this texture right here is now mapped to all these objects. Yeah, that's pretty nifty. That's just a basic node setup. I think that's pretty much as basic as you can get. Yeah, and you can see that these different sliders control, like, say, the metallic property if you have a metal object. Specular property increases the intensity of, like, the reflection of lights. The roughness controls how shiny something is, so if we set it to 1, it's like a carpet. It doesn't reflect anything. And if we set this to 0, it's reflecting the lights in our scene because we don't have any reflection maps or anything set up. We're not going to worry about that. Let's just set that back to the default value of 0.5. Clear coat, we're not going to worry about any of the other things. Just skip on down to emission. This is what you would use if you wanted to make glowing objects. So let's say we want to hook up this color output into the emission input, and now it's just glowing like a PlayStation 1 game. So it's just kind of flat shaded. You wouldn't really want this. You'd only really be using the emission input if you had a texture or a material that comes with an emission map. Same with adjusting like the metallic, specular, roughness, and all those other properties. You'd really only be using those with a material that comes with those maps in the download. So alpha as well. Alpha controls the transparency. You'd be hooking up an opacity map, or opacity, I don't know how to pronounce it. You'd be hooking up that map to the alpha input over here, and that just controls how transparent, or what parts of the object have transparency. And since we're not using a map and it's just this slider, it's controlling the entire object that the material is applied to. So that's not going to work, as you can see, unless we have that enabled in the material settings. So to adjust that setting, we're going to hop on over to the Home tab, switch over to Render View so we can see what's going on. And down here in the material properties with any of these objects, or whatever object you have the material applied to, we're going to scroll down over here and go down to the settings drop down. And in that, we're going to adjust the blend mode. So right now it's set to opaque. Alpha clip, it's going to be either transparent or not transparent. There's going to be no blending or anything in between. But if we set it to alpha hashed, and we go back to the shading tab and adjust the alpha slider, you can see that the transparency of the objects are starting to change. And it's got like kind of a grainy hashed look to it. That's what alpha hashed means. If you wanted like a smoother kind of transparency, or depending on what texture you're using, you're gonna want to use either hashed or blend, and you'll know which one to use in either situation because it'll just look better. But if we wanted to change it to alpha blend and we didn't want to go back to the Home tab, we can just hover our cursor over or select the home or the node editor window and hit N, and it'll open up this nice menu on the right side. And if we go down to the options tab, we can see that the blend mode settings are actually right here. So we can click on alpha hashed and change that to alpha blend, and now you can see that it's got a nice smooth blended kind of transparency. There's no grainy hashedness to it. But in some instances, it's going to give us a weird glitchy object like we have over here. And to solve that, we're going to turn off backface culling. So this is more akin to what you would expect with a transparent object. What backface culling does is that it removes the faces on the other side of the object. So if I go inside of this cube and disable backface culling, set the alpha back to 1, you can see that there's faces on both sides of the cube. Also, alpha blend introduces this really weird glitch for completely opaque parts of the material, so that's another reason you'll want to enable backface culling for this. Just check that and you can see it looks fine. It just hides all the faces on the side that you don't see usually. So let's go back to opaque and turn off backface culling, just because, so we can have both sides of this plane. And let's hit N again to hide this right menu, and we can also hit T to open a menu in the top left over here that gives us different selection options. So we can have like the select box, which is this. We can have the lasso, which gives us like fancy random custom selection sizes if you want it to be like that. But I'm just going to leave it on the select box. There's also the annotate tool, which lets us write wherever, and also the link cut tool, which if we just drag it across a connection, it'll cut that connection. So it allows us to disconnect a lot of things at a time. But we're just going to go back to the select box and reconnect that. So let's start putting in some other maps. So I'm going to click on this texture node to this image texture node to select it, and then Shift D on the keyboard to duplicate it. So we're just going to drop it underneath over here. Select both using a box select, so that's just clicking and dragging, and we'll move it up a bit, just to save space at the bottom. And we can either hit this X button to get rid of the texture completely, or we can just click on this folder button. So let's just open up a new texture, go back to where our textures were extracted to before, or wherever your textures exist for that material, and let's click on the roughness, or whatever the next thing is in line. So we're going to take the color output of this image node and drag it into the roughness input, the corresponding input based off the name of the texture. And if we zoom in on this cube right here and go to a shallow angle, and we just disconnect this roughness node, you can see that all the reflections, the specularity, that's this. So if I change it to 0, you can't see it. The specularity is just completely uniform on the entire face of this object, but if we plug this in, light interacts with it in a different way, because the roughness material is basically just telling Blender what is reflective and what isn't reflective, based off of the range from black to white on this texture. So that's roughness. Next thing we're going to set up is ambient occlusion, and that's abbreviated by AO in this case. So we're going to select this image node, duplicate it, and put it on top of our diffuse texture. Because Blender doesn't actually have an input for Principled BSDF, you have to do it manually in a kind of janky way. We're just going to select those and move it to the left. Shift A again on the keyboard, and we're going to be adding a Mix RGB node. So we'll just search up Mix, and then it's right under here. Plop that over there, and we're going to be dragging the color output of our roughness, or our ambient occlusion map, sorry, so let's just open that up. Drag the color output of our ambient occlusion map into color 1, and then the output of Rock's ground, the diffuse map, into color 2. And just so that we can see what's going on in real time, let's drag the color output of the mix node into the base color. So, it looks terrible. It's white. If we adjust the factor, you can see that we're interpolating between the two textures, which is what you'd expect a mix node to do when you have the blending mode set to mix. So let's just drop this down to 0.5 again, and you can see there's a bunch of different blending modes, and these are pretty much the same as all the blending modes you'd see for any program where you're working with images or videos or anything. For this, we want to be using the darkening, the ones that darken stuff, so that's under this first category up here. I find that multiply works the best, so if we actually invert these inputs by just dragging the first input onto the other one, if we switch them, drag the factor up to 1, you can see the ambient occlusion texture, the AO texture, is giving a little bit more definition and detail to the dirt texture. So just setting that to 1 is multiplying one texture by the other, and it's just making it darker in certain areas to give it more definition. If we switch it to darken, it doesn't really do anything. It's not a prominent change at all. Then color burn just doesn't look right. It looks like a really well done steak, and we don't want that because this is dirt, not Pompeii. So let's switch that back to multiply, and we're pretty much done for the ambient occlusion nodes. So let's go on to the next texture, which in this case is our normal map. So we're going to duplicate our image texture node again, put this a little bit off to the side because we're going to be adding another node. Click the folder icon and open our normal map, and Shift A again on the keyboard, search, and we're adding a normal map node. Not the normal, but the normal map. We're just going to put that in between our normal map and the Principled BSDF, drag the color output into the color input, and the normal output into the normal input. So, you can see that there's not much change, but on more complicated meshes, you'll notice a very drastic difference, and it will definitely not look right. And that's because normal maps always have to be in the non-color color space. So just click on sRGB over here for your normal map, and then change that to non-color. And if you look at it from a shallow angle again and grab one of the lights, so I'm just going to click on this point light right here, zoom in, and I'm pressing G to move it around. G and dragging with my mouse. You can see that those rocks right here are kind of getting a shadow on it when I move the light, as if there was actually geometry there that's being displaced. But it's not adding any extra geometry, it's just Blender is tricking us into believing that there is stuff there that's casting a very small shadow based off of the normal maps. And there's plenty of good videos on YouTube if you want to learn how that works, but it's a process. We're not going to go into that. So you can adjust the strength of the normal map by using this control, and I would just leave it at 1. It kind of looks terrible if you set it to any value higher than 1 in most cases, so just don't worry about that. If we quickly disconnect our base color, as well as our roughness actually, you'll be able to see just how much the normal map is doing. So you can see it's adding a lot of nice bumpy detail to our object. So it's very important. Normal maps do a lot, but only really in EEVEE if you're using cycles with displacement maps, if we're going on to next. Normal maps don't really apply. So let's just disconnect the normal map and see what the roughness map is doing. And if you look at a shallow angle, you can see ever so slightly. You might not be able to see it with a YouTube compression, but you can see that there's little patches of shinier areas, more reflective areas where the rocks are, and it's just not reflective where the dirt is. So let's hook up all our nodes again, and that's all for this material, pretty much, for EEVEE, the default render engine in Blender. We're going to use, for EEVEE, that's all for this material, that's all we're going to be hooking up for this material in EEVEE, the default render engine in Blender. But as I said earlier, if your material comes with other maps, like emission maps, opacity maps, metallic or specular maps, you just duplicate the image texture node and hook it up accordingly to the corresponding property over there. But we're not going to worry about that because Rock's Ground 02 is a simple material and doesn't need all those other fancy things to look good. Just a quick tip before we move on to displacement maps. If we're not going to be UV unwrapping any of these objects, like if you were modeling something yourself and making a more complex object, you'd be UV unwrapping it and telling Blender where the texture goes using the UV editing menu. I just go into edit mode and select things. You can see the UV over here. So this is just the default UV map that Blender gives these default objects. And if we go back into the shading tab, we can actually manipulate this. So we can rotate, scale, and move all of these textures, the texture coordinates. And we can do that by adding a mapping node. So Shift A on the keyboard, mapping, and we're going to plug the vector output of mapping into the vector input of these image texture nodes. And you'll start to see that it's going to look absolutely terrible. And that's because we're missing another component to this. And that's the texture coordinate node, which is going to tell Blender what to do with all of these, or like how to actually map the material. The mapping node only lets the user adjust the location, rotation, and scale individually, but it still needs a vector input for Blender to know where to put the material. So Shift A again, search, let's add the texture coordinate. Just drop it into the node editor, and we're going to use the UV map and hook that up to the vector input. So UV vector output to vector input on the mapping node. And you'll see that it looks exactly the same as it did before. So if you don't plan on adjusting the location, rotation or scale of the texture, you don't need the mapping and the texture coordinate node, because the image texture, if you don't have anything hooked up to the vector, it's just going to use the UV as it's just going to use the UV by default. So don't worry about that if you're not going to be manipulating the texture in any of these ways. Just a quick rundown of the other things that the texture coordinate node can do. You can use generated textures, so Blender is just going to generate coordinates for the texture onto the object based off of the object. We rotate it, you can see it's not changing, and if we go into edit mode, you can see that the texture, the way that it looks, is kind of changing based off of the position of all the edges and the faces. If we go to normal, it does something very similar, except it's based off of the direction in which the faces are facing. So that's why Suzanne over here, the monkey, has different colored faces or has a different color for each face. It's just basing it off of the normal, or the direction in which the face is changing. And that's also why the sphere looks so smooth, because it's a sphere. Let's go back to over here. If we use the object vector input, it'll be basing it off of either the object that the material is applied to or an external object. So this is really useful if you want to animate the texture. We can Shift A over here in the viewport and add an empty. I'm just going to use plane axis. The empty is selected by default since we just added it, and I'm going to hit G to move it around so we can see it. Select one of the objects and click on the eyedropper tool in our texture coordinate. Select the empty, and now if we move the empty, we can actually animate the position, scale, and rotation of our texture based off of the position of that empty, or those transform properties of the empty. So camera, window, and reflection are all pretty similar. Hook that up to the mapping vector. You can see that camera maps the texture to the object based off of the angle at which your camera is facing. Window just keeps the texture in the same place the entire time, but it's based off of the size of the window. So when you're actually rendering something, it's going to be based off the size of the render, like the resolution dimensions. So if I scale the window all the way to the left like this and make it really wide, you'll see that the textures are now stretched. And if we do the opposite, the textures are now squished. So let's just leave that in the middle, change it to reflection, and it's basically just using whatever Blender uses to calculate reflections on materials. But we're going to be using UV over here. And I just wanted to tile the scale by 2. So you can see that now there's texture repetition, so this is being tiled by 2, just for an example. You can't really see it on the other objects, but on the plane it's very evident. So yeah, that's pretty much all you need to know when you're setting up PBR materials for EEVEE. But what if you want the material to look really nice and bumpy and detailed like it is in the example on TextureHaven.com? Well, you can't do this in EEVEE, so we're going to have to hop on back over to the Home tab. This is a good time to save your file. I'm going to go to Save As and just call this PBR tutorial. So we're going to go to the Render Properties tab over here and set the render engine to Cycles. And we're also going to need to change the feature set to experimental, but I'll get back to that later. Also, always make sure that you have the GPU selected if you do have a GPU and you want to use cycles, because this will just make things render a lot faster. So to make sure that we have the GPU enabled, let's go to Preferences, Edit Preferences, and then System, and then you can see I have Optics selected. So none means it's just going to use the CPU. CUDA, if you have an NVIDIA card that's not an RTX card, you're going to be using CUDA most likely. And if you have an RTX card like I do, you want to be using Optics because it's the fastest render engine in Blender for cycles. So we have our GPU selected over here. That's what we want. Just exit out of settings, and we have the optimal settings for this, what we want to do. So now you can see that we're now using the ray tracing cycles engine, so every object is flashing every time you have a screen, a viewport update, probably giving some people seizures, and that's unfortunate. So let's select our material output over here, drag that to the bottom, just so that it's easier to access, and we're going to be adding a displacement node. So Shift A on the keyboard, search and add displacement. So we're just going to grab one of these texture coordinate nodes, Shift D to duplicate it. If you're using the mapping node setup thingamajig duo over here, we're going to grab the vector output of our mapping node and put it on the vector input. And grab the color output of our image texture and put it into the height of the displacement node. And we're going to load the displacement texture, also called height map in this case, and output displacement into input displacement. And nothing's changed. So in Cycles, what you have to do to enable displacement is go to our material settings. So that's hitting N on the keyboard in the node editor or on the home tab that's in the material properties and scrolling down over here to settings. So now you can see we have Cycles enabled. It's using ray tracing, so it's going to take a little bit longer for the viewport to update, but that's fine, at least on higher end graphics cards. So let's grab our material output. I'm selecting it and hitting G to move it around. I'm just going to move this to the bottom over here so it's easy to access. And we've got to remember to hook our normal map back up just from there. So let's grab one of our image texture nodes, duplicate it, grab the mapping output and put it into the vector input. Again, you don't need this if you don't want to mess with these shenanigans over here. But since I am using it for this example, I got to hook that up so it matches the rest of the textures. I'm going to hit on this, I'm going to select this folder icon over here and select our height map. This is also called displacement map in some cases, depending on whoever makes your texture. I don't know, I prefer diffuse map over color map. It's just the personal preference of whoever's naming the textures when they create it. So let's grab our displacement node, Shift A on the keyboard and hitting search, and we're adding displacement. Drop that there, get the color output of our image texture node and drag it into the displacement node's height input. And we're also going to load up that texture. Yeah, we already did. Okay, so grabbing the displacement output, setting it to the displacement input, and you can see nothing's changed. So that's because in Cycles, you actually have to enable displacement in each material settings. And before we do that, we're just going to drag the normal map into the normal input of the displacement node. So yeah, we're just going to hit N to bring up this menu over here, and you can see that the settings menu has changed since we're using the Cycles render engine. Now we have this displacement property over here, and we want to change bump only to displacement and bump. And now you can see it's looking a little wonky on those other objects, but things are definitely being displaced now. Again, if you're doing this in the Home tab, you can just scroll down to the bottom of the Material Properties tab, and then it's in the Settings drop down right here. Bump only, displacement and bump. So, we've got a couple things wrong over here. First of all, let's take a look at the sphere. So I'm selecting the sphere and hitting period or delete on the number pad on my keyboard to focus on the object. You can do that with anything and it'll focus the camera on it. So on the sphere, you can see that all the geometry is all torn and disconnected. If we turn the normal map up, it gets even worse. It's just a complete disaster. So to fix this, we actually have to turn the strength of our normal map down to 0. And now it can coexist with the bump map by not existing. But let's not worry about that. So the second issue we have is that unlike normal maps, which only work in tangent space, which is just the surface of the object, displacement maps work in object space. So this is object space right here. Me selecting this vertice and manipulating it, that's object space. This is what displacement maps manipulate. So it's actually displacing the geometry of your object. And as you can see, as for this plane with one face, there's no geometry to displace. So to fix this, we're going to hop on over to the Home tab, go to our render properties, and change the feature set to experimental. And this is unstable because it's experimental, so it might cause crashes and other stuff like that. So just make sure that you're saving every so often. So let's drop on down to the modifier properties. I'm going to add the subdivision surface modifier, change it to simple, and enable adaptive subdivision. Adaptive subdivision is not available unless you're using the experimental feature set. So just remember to have that on. If we hit period to focus on our plane here, you can see it's already being displaced more like what we want it to look like over here in this example. But there's not a lot of, it doesn't have a high resolution when it comes to those smaller rocks and smaller objects. There's just not a lot of detail on it. So to fix that, we're going to reduce the dicing scale. So we're going to select this and drop it down to 0.5. And now you can see that we've got a lot of definition and detail on our plane here. And this is pretty much what we want it to look like in the end, because using displaced materials like this isn't really optimal if you want to have close-up shots on the dirt. Really, you should just be scattering objects on it. But if you want to have nice far-away shots like this, it looks really decent, and it looks really good for that purpose. You just don't want to be doing super up-close stuff with it. So that serves our purpose. Our plane's pretty much done. If we go onto the shading tab, we can actually change the mid-level and the scale. So what the scale does is it literally just changes how dramatic the bump is going to be. I'm going to set that to the default of no, not the default of 0.5, but I'm just going to set it to maybe 0.7. 0.7 is a good value for the plane. Nope. There we go. And we're also going to, we don't really need to adjust the mid-level, but basically what the mid-level does is that it sets wherever the base of the displacement is going to be. Oh, Blender froze. All right. That's one of the advantages, I guess, of using the experimental feature set. It's going to cause a lot of crashes, so you better make sure that you're saving. Let's just load this back up here, and actually our progress is going to be gone. We go back to render view, yeah. So to recover your progress in Blender if anything crashes, it has autosave. So you can actually go to recover, autosave, sort by date modified, and you can see that we have an autosave file right here. And if I go to render view, we're closer to where we were before than before that. If you want to make sure that you have autosave enabled or you want to turn up the frequency, you can just go into our edit properties or edit settings, and then it's somewhere in here. It's under save and load, and then you have autosave checked. It's probably good to set the timer to 1 minute, honestly. Okay, so press period, and let's just go back to what we were at before. We just gotta add the subsurf modifier. There we go. So, change to rendered mode, and like I was saying, set this to 0.7. And what mid-level does is that it changes whatever point on the object is going to be 0, if you want to think of it as that. So things are going to be scaled or are going to be bumped up and down from that point. So let's say this right here is 0, where it's relatively flat, and then the positives are going to be where it's bumping up, and the negatives are going to be bumping down. So if we set the mid-level to something like 0, it's just going to move that 0 point where it's flat up, and then turning it up is going to move it down. So we're going to leave that at 0.5, which is the default. I see no reason to adjust that most of the time. And so the plane's done. For the rest of these objects, we're going to be wanting to edit this material on an object-by-object basis. So let's just rename this to plain dirt and hit this little copy icon over here to create a copy of the material. Now we can see that we have 2 plain dirts, and I'm just going to probably do the cube next, so we'll call it cube dirt. And now only the cube has... Okay, well, all these objects have the cube dirt material. Whatever. We'll take care of that later. Okay, so for the cube, we have to add geometry to it. So let's go back to the Home tab, focus on it using period, and add the subsurf modifier, simple adaptive subdivision, reduce the dicing scale to 0.5 as usual, hop on over to the shading tab, and now we want to adjust the mid-level until it looks proper. So if I set it to 0.2, it looks more like a cube that has some displacement on it, and that's pretty much what we want. So I guess the cube's done. Let's move on to the sphere. Obviously there's going to be some problems with the sphere because of the way that the geometry is, so if we use tab to go into edit mode, you can see that the UV sphere converges at one point on the top. So on the poles, you're going to have kind of like a pinched look on the texture, and on the equator, you're also going to have some weird distortion over there. So to fix that, we can actually go up to our texture coordinate and change it to one of the different modes. So object is not much better. Generated isn't really much better either. I don't know, you just have to figure out a way to UV unwrap this and make it look good in a different way. I don't know, let's not worry about that. I'm going to switch it back to UV. Let's not worry about the sphere. Focus on Suzanne the monkey. I'm going to right click it and go to Shade Smooth. And I'm also going to duplicate Cube Dirt and change it to Monkey Dirt. And I just want to bump up the scale a bit more so that it looks a little bit better when we add the subsurf modifier. Period to focus. Add subdivision surface. Simple. Adaptive subdivision. Drop the dicing scale to 0.5. And now we have a PBR material on a PBR bumped dirt monkey. Also, I just wanted to say that in the case of the sphere, if we wanted to have a sphere with better topology, that's what this is. You can see that it's a UV sphere topology with a convergence on the top. If we wanted to have better topology that won't give us that weird distortion, like the equatorial distortion and the stuff on the poles, we can actually grab this cube here. I'm going to hit delete on the keyboard, on the numpad to focus. Go into edit mode. Press A to select, make sure that just the cube's selected. There we go. Hit A to select all the vertices or all the faces or all the edges, depending on what selection mode you have. There. And then you're going to right click it, hit subdivide, do that a few times. So now we have a grid of faces, vertices, and edges. And we're just going to tab out of edit mode, add modifier, cast, and we're going to grab the cast modifier using these dots on the right here and move it above subdivision. And then set factor to 1, and now we have a sphere. It just looks a little bit weird because there's kind of a seam there, but we don't have to worry about that for now. So the point is that if we apply cast, and then keep that subdivision modifier on there, go into the shading tab, hit period or delete on the keyboard to focus, duplicate this, then we have sphere dirt, and we can adjust the mid-level again, whatever suits it. And then we can also adjust the scale, and now we have a more properly bumpy sphere. You can see the one with quad topology, that's a cube. So a cube is a quad, it has that kind of topology, and we're just turning that into a sphere, as you can see over here, versus the UV sphere topology. It looks a lot better, and we can also resolve these seams over there by changing the mode in the texture coordinate. So we could use generated, I don't know, normal, object. I don't know, you'd have to play around with it, but eventually you could get something that works properly. Yeah, let's just not worry about that. It's fine. It looks a lot better than before, but yeah. Just so you know, it works a lot better on cubes that were turned into spheres rather than just the default UV sphere. Nothing against the default UV sphere. It's just kind of useless in a lot of situations. I don't tend to use it much. So yeah, that's pretty much all I've got to say about this. If you have any questions, just ask below and I'll try my best to answer if I have time. And yeah, I hope you learned something. I hope this helped. Thanks for watching.